class, our topic for today is properties of fluids. Now, what is fluids? Fluids are substances capable of flowing, having particles which may easily move and change their relative position without separation of mass. Now, mass is one of the properties of fluids. Now, mass is a quantitative measure of the particle, and its unit is kilograms. Okay. Now, another properties of fluid is the weight. Okay, weight. Weight is a gravitational pull of mass, and its unit is in Newton, or it could be kilonewton also. Now, how do we get weight? Weight is just equal to mass times the gravitational acceleration, which is equal to 9.81 meters per second squared. How about density? Density is just equal to mass per unit volume. Okay, mass per unit volume. And we know that the unit for mass is kilograms and the unit for volume is cubic meter. So that would give us kilograms per cubic meter. And that will be the unit for density. Okay? Okay. Now take note, class, that the density of water at 4 degrees Celsius is equal to 1,000 kilograms per cubic meter. Mind that 4 degrees Celsius is the temperature at which liquid water has the highest density. Now, for the unit weight or specific weight, it is the weight of unit volume of a fluid. Now, it is equal to the total weight over the total volume. And the specific weight of water at 4 degrees Celsius is equal to 9.81 kilonewton per cubic meters. Now, what is specific gravity, class? The specific gravity is the ratio of the specific weight of the fluid to the specific weight of water at a specified standard temperature. And specific gravity is dimensionless. How about viscosity? Viscosity is the property of a fluid which determines the amount of its resistance to shearing stress. Okay? Viscosity is what we call in Bisaya as iyahang lapot ba, iyahang kalapot. Capillarity is that liquids have cohesion and adhesion. Okay? Cohesion and adhesion, both of which are forms of molecular attraction. Cohesion enables a liquid to resist tensile stress, while adhesion enables it to adhere to another body. Okay? Now, capillarity rise or depression is equal to Okay. Now, depression is denoted with H, and it is equal to 2 times the surface tension. This is the surface tension. Surface tension is the property of the surface of a liquid that allows it to resist an external force. Times the cos theta all over the specific weight times the radius of the tube. Okay, this is the radius of the tube. Now, this is the specific weight. Okay. Now, what is this? What is this theta? This one is the wetting angle. Okay? This is the wetting angle. Let's move to the density and specific weight of gas. Okay, density or the specific weight of gas. Now, in your thermodynamics, I assume that you already know PV, the ideal gas equation, PV is equal to MRT. Because you're already done with your thermodynamics. Now, to get the density of gas, we know that density is equal to mass over volume. So, mass over volume from this formula is equal to the absolute pressure over the gas constant R times the absolute temperature. Okay? So, this will be the formula to get the density of gas. Now, class, take note that the formula to get the pressure inside the droplet of liquid is equal to 4 times the surface tension all over the diameter of the droplet. Okay? Okay, let's have a sample problem. Calculate the density. Specific weight of oxygen with gas constant R is equal to 0.26 kilonewton meter per kilogram Kelvin at 40 degrees Celsius and 100 kPa absolute. So, to find the density, we will use the formula P over RT, where P is the absolute pressure and R is the gas constant and T is the absolute temperature. So, we already have the absolute pressure, so it is equal to 100 all over the gas constant R, which is also given 0.26 kilonewton meter per kilogram Kelvin. By the way, this one is kPa. Okay. Times the absolute temperature. Now, to get the absolute temperature, we have to add 273 to 40 degrees Celsius. So, this will be in Kelvin. Okay. Now, take a look at this. 100 kPa, and the breakdown unit for kPa is kilonewton per meter squared all over 0.26 kilonewton meter per kilogram Kelvin times 40 plus 273 is equal to 313 Kelvin. So, this one will be cancelled. This one also. So, that will give us an answer of, okay, let's see, 100 divided by 0.26. 313. Okay, that will give us an answer of 1.229 and a unit of kilograms per cubic meter. Okay, fair enough. Okay, let's have another example. A tank of mercury has a mass of 12,947.20 kilograms and a volume of 0.952 cubic meters. Find A, the weight, B, the specific weight, C, the density, and D, the specific gravity. Okay. First, we have to find the weight. So, the formula for weight is mass times the gravitational acceleration. So, we have the mass, which is equal to 12,947.20 kilograms times the gravitational acceleration, which is equal to 9.81 meters per second squared. So that would give us an answer of 947.20 times 9.81. 12.032 Newton. Okay, this one is Newton. Divided by 1,000, that would give us an answer of 127 kilonewton. So, A here, which is the weight, is equal to 127 kilonewton. So, let's solve for the specific weight. Okay, let's solve for the specific weight or the unit weight. Specific weight is equal to the total weight over the total volume. So, we have the 127 kilonewton as the weight and the volume is 0.952 cubic meter. So, that would give us an answer of 133.4 kilonewton per cubic meters. This will be our specific weight. So 133 kilonewton per cubic meter. Okay, now let's solve for the density. Let's solve for the density. Okay, density is equal to mass over volume. So, we have the mass, which is equal to 12,947.20 kilograms over the volume, which is equal to 0.952 cubic meters. So the answer for that is the answer for that is 13,600 kilograms per cubic meters. Okay. 13,600. And lastly, we have to find the specific gravity. Now, specific gravity is the specific weight of the substance over the specific weight of the water. Okay, now, what is the specific weight of the substance? It is 100. The one we solved earlier, it is 133 kilonewton per cubic meter. Divided by the specific weight of water, which is equal to 9.81 kilonewton per cubic meter. And that would give us, okay, let's calculate. 133 divided by 9.81. That would give us an answer of 13.56. Okay, 13.56. The specific gravity is dimensionless. So the answer is 13.56. Okay, we're done.